When you think about alien planets, Mars might not seem as strange or unfamiliar as you'd expect. In fact, it shares quite a few similarities with our own planet, Earth. One of the most surprising parallels is the length of a day. A Martian solar day, or SOL, lasts about 24 hours, 39 minutes, and 35 seconds, just a little longer than an Earth day. That slight difference means that if you lived on Mars, your daily schedule wouldn't need too much adjustment. It's an odd feeling knowing that this so-called alien world ticks to a rhythm close to ours. But time on Mars stretches out in other ways. A year on Mars is significantly longer than it is here on Earth. While we circle the Sun in 365 days, Mars takes about 1.88 Earth years to complete one orbit. That translates to 1 year, 320 days, and roughly 80.2 hours. This extended year is because Mars is farther from the Sun and travels in a wider orbit. The extra distance means it takes longer to make its journey, much like a runner on the outer lane of a track having to cover more ground in the same lap. Among all the planets in our solar system, Mars has seasons that most closely resemble those of Earth. This is mainly due to the similar tilts of the two planets' axes. Earth is tilted at 23.5 degrees, while Mars is tilted slightly more at 25 degrees. That slight difference is enough to create comparable seasonal shifts. In other words, Mars has winters and summers just like we do. But the Martian versions are far more extreme. Its temperature swings are much more dramatic, thanks to a thinner atmosphere and its greater distance from the Sun. In fact, the temperature on Mars can vary massively depending on both the season and the location. During the polar winters, it can drop as low as -143 degrees Celsius. In contrast, some equatorial regions can reach highs of around 35 degrees Celsius in summer. That's a vast range of temperatures, and it gives us a glimpse into how harsh and unpredictable the Martian environment can be. These polar extremes are especially fascinating because they show just how alien and intense the planet truly is, despite the surface-level similarities it shares with Earth. One of the most intriguing features of Mars is its polar caps. Much like Earth, Mars has icy poles that grow and shrink with the seasons. However, there's an important difference. During each pole's winter, the pole is plunged into continuous darkness, similar to what happens on Earth, but on Mars it gets so cold that the thin atmosphere itself begins to freeze. Carbon dioxide in the air solidifies and falls to the ground as slabs of dry ice, building up on the polar caps. This adds an eerie, almost otherworldly twist to Mars' seasonal behavior. Now, while those seasonal CO2 deposits are strange enough, the permanent structure beneath them is even more interesting. The core of Mars' polar caps isn't primarily made of carbon dioxide ice. Instead, they're built from layers and layers of water ice. These layers are like pages in a book recording climate patterns for millions of years. Over time, as the temperatures rise and fall with the seasons, the ice at the poles expands and shrinks. In satellite footage, you can even watch these changes. The caps literally wax and wane as Mars transitions from winter to summer. Another eye-catching detail about Mars' polar caps is the presence of strange, spiral-shaped patterns etched into the surface. These beautiful spirals are visible in both the northern and southern polar regions. Scientists believe these patterns are the result of the Coriolis effect, the same force that influences wind and ocean currents here on Earth. On Mars, it affects the movement of ice and wind in such a way that these stunning swirls emerge naturally. It's just another example of how natural forces can create order and beauty in even the most alien landscapes. The carbon dioxide that builds up during the Martian winter doesn't stay in place forever. When spring arrives, that frozen CO2, dry ice, begins to sublime, meaning it turns directly from solid to gas. This process creates a powerful shift in the surrounding environment. The sublimation can generate wind speeds of up to 400 kilometers per hour. That's fast enough to significantly disturb the Martian surface, especially since much of it is covered in fine reddish dust. These fierce winds kick up dust storms, reshape dunes, and play a huge role in Mars' unique and dynamic climate. Despite all these similarities, Mars and Earth have plenty of differences as well. One major difference is size. Mars is much smaller than Earth, with a diameter of only 6,779 kilometers compared to Earth's 12,742 kilometers. It's also far less dense, which has a direct effect on the gravity experienced on the surface. With weaker gravity, objects fall more slowly and everything weighs less. This difference in gravity might not sound like much, but it changes a lot, from the way structures would be built to how a human would move or even breathe if they lived there. To give you a better sense of what this difference means, let's imagine a simple demonstration. Picture dropping a ball on Earth and then dropping it on Mars. If you adjust the timing to match the gravity, you'd notice that the ball on Mars falls much slower. That's because Mars' gravity is around 62% weaker than Earth's. In practical terms, if you weigh 100 kilograms on Earth, you'd only weigh about 38 kilograms on Mars. That's a big drop, and it would make everything from walking to lifting objects feel completely different, almost like being in a dream. What's even more curious is how this low gravity compares to other planets. For instance, Mercury is smaller than Mars, only about 4,879 kilometers in diameter, yet it has nearly the same surface gravity. Mars only has a 1% stronger pull. This tells us something surprising about Mercury's density. Even though it's smaller, it's packed with more material, making it denser than Mars. This comparison really helps illustrate how size isn't the only factor when it comes to planetary gravity. Density plays an equally important role in determining the experience of weight on a planet's surface. One of the most impressive outcomes of Mars' low gravity is its towering geological structures. Take Olympus Mons, for example. This is the tallest volcano, and the second tallest mountain, in our entire solar system. It's only narrowly beaten in height by Rhea Silvia Peak, which lies on the asteroid Vesta. But some argue that comparison is a bit unfair. Rhea Silvia sits inside a crater, so its height is measured from the bottom of that depression, giving it a boost. Olympus Mons, on the other hand, rises cleanly from the surrounding terrain, a true Martian giant. Olympus Mons is an absolute behemoth. It stands at a staggering 22 kilometers tall, 3 times the height of Mount Everest. But what really sets it apart is its width. This volcano stretches over 600 kilometers across, giving it a massive footprint on the Martian surface. Despite its enormous size, it isn't steep. Olympus Mons is a shield volcano, meaning it has a broad, gentle slope, only about 5 degrees on average. So even if you stood at the summit, you wouldn't be able to see the base. The planet's curvature would hide the rest of the mountain. Because of its massive size, Olympus Mons is visible from space with surprising clarity. On topographic maps, it appears like a giant bump, or even a pimple, on the side of the planet. At the summit, you'll notice several collapsed craters. These features formed when parts of the volcano's top caved in after eruptions. Surrounding the summit is a cliff face up to 8 kilometers high, forming a sharp boundary between the volcano and the surrounding plains. The overall appearance is striking, and it's one of the clearest signs of just how active Mars once was. Another dramatic feature on Mars is Valles Marineris, a canyon system so vast it makes Earth's Grand Canyon look like a scratch. Valles Marineris stretches across the Martian surface like a colossal scar, spanning thousands of kilometers. It's about 3 times longer and 4 times deeper than the Grand Canyon. Every time you look at it, it's hard not to be amazed by the scale. It's believed to have formed through a mix of tectonic activity and erosion, and its immense size offers a glimpse into the powerful geological forces that once shaped this alien world. And you'll notice that as the dust on Mars gradually wears away, the terrain underneath tells a very different story. What initially appears as smooth and lifeless turns into a rugged, textured landscape full of hidden ridges and shapes. These patterns only emerge after years of slow erosion. We've seen how impact craters on Mars disrupt the dust layer and reveal the features underneath, but one example stands out in particular. After a meteorite strike, the heat from the impact actually melted the underground water ice, creating a visible trail as it trickled away from the crater. The colors shown here are just used to indicate elevation, not actual hues. The Martian surface is breathtaking, but getting a clear view of it is often a challenge. Mars experiences frequent and intense dust storms. Winds sweep across the loose dusty ground, creating enormous clouds that can span entire regions or even engulf the whole planet. The sheer scale of these storms is hard to comprehend until you see them from space. In 2012, an orbiter captured a massive dust storm that visibly altered the planet's appearance within just a week. In a photo taken afterward, you can even spot the storm reaching all the way up to the North Pole. These global dust storms are completely unlike anything we experience on Earth. They're so powerful and far-reaching that they've inspired dedicated research and even full-length videos explaining how they work. Now let me show you something else intriguing. What do you think causes those strange swirl-like patterns across the Martian surface? As it turns out, they're created by dust devils, mini tornadoes that frequently form across the dusty plains. They've been captured multiple times by orbiters passing overhead. One image shows a colossal plume over 800 meters high and 30 meters wide, with its shadow stretching nearly 2 kilometers across the surface. Even more impressive is that we've seen dust devils in motion, thanks to cameras mounted on Mars rovers. With all these dust devils and massive storms, you might assume that Mars has an atmosphere similar to Earth's. But that couldn't be further from the truth. In fact, if you were standing at 38,000 feet above Earth right now, in an airplane for example, the air would already feel incredibly thin. Now imagine going even higher, all the way to 120,000 feet. That's roughly the same atmospheric pressure you'd experience standing on the surface of Mars. Not only would you struggle to breathe, you'd need a full pressure suit to survive. And that's before we even talk about the composition of the air. Mars' atmosphere is made up of about 96% carbon dioxide, which means there's practically no oxygen to breathe. So, if we ever plan on visiting Mars, we'll need proper gear to stay alive. But even with all these challenges, Mars still manages to surprise us with its beauty. For example, Martian sunsets have a soft, bluish tint due to the way light scatters in the thin atmosphere. The rovers have captured a few of these sunsets, and they are absolutely stunning. Proof that even in such a harsh environment there is beauty to be found. Interestingly, Mars didn't always have such a thin atmosphere. The presence of dry riverbeds all over the planet is strong evidence that at one time, Mars had thick enough air pressure and warm enough temperatures for liquid water to flow freely across its surface. So what happened? Scientists think that billions of years ago, Mars lost its magnetosphere, the protective magnetic shield that surrounds planets like Earth. Without it, the sun's solar wind was able to slowly strip away the Martian atmosphere, atom by atom. Even today, orbiters around Mars have detected traces of ionized particles drifting away into space, remnants of an atmosphere long gone. Now let's turn our attention to Mars' moons, Phobos and Deimos. They're not the kind of majestic, spherical moons we're used to seeing. Instead, they're small, oddly shaped, and appear more like asteroids than moons. Compared to Earth's moon, they're tiny. If you looked up from the Martian surface, you'd see Phobos as a small object in the sky, far less dominant than our moon appears from Earth. That said, Phobos is actually closer to Mars than our moon is to Earth, only about 6,000 kilometers away. That's roughly the distance between London and New York. This close proximity gives Phobos the illusion of being larger in the sky than it actually is. In contrast, Earth's moon is a whopping 384,000 kilometers away. You could fit several Earths between our planet and the moon. But when it comes to Mars and Phobos, you'd barely squeeze one Mars between them. That closeness makes Phobos unique, but Deimos is even more different. It's so small and so far from Mars that it appears in the sky like a faint star rather than a moon. Still, both moons have their own kind of strange, irregular charm. And speaking of Phobos, there's something truly spectacular I want to show you. It's a solar eclipse on Mars, captured by one of the rovers. Watching it is nothing short of magical. As Phobos drifts in front of the sun, you can clearly see its jagged, potato-like shape. The shadow it casts causes a noticeable dimming of light around the area, almost like someone turned down a dimmer switch. It's surreal to witness an eclipse from another planet, especially when most of us haven't even seen a total eclipse here on Earth. It really puts things into perspective. Before we wrap up our journey across Mars, let's take a moment to appreciate something truly humbling. Ever wondered what Earth looks like from Mars? Take a look at this picture. You'll have to squint a bit because Earth appears as nothing more than a faint dot in the night sky, almost indistinguishable from the stars. But that tiny speck contains every person you've ever known, every story, every memory. It's a poignant reminder of just how small we really are in the grand scale of the cosmos. From Mars, we're barely a whisper in the night sky. Here's a slightly clearer image of Earth, taken from around 80 million kilometers away. It's still blurry and distant, but knowing that everything we are is in that small dot is a powerful thought. That dot holds humanity, our past, present, and maybe even our future. And it's images like these that fuel the dream of one day stepping foot on Mars ourselves. Because Mars, for all its dust and danger, is still the planet most likely to welcome our first steps beyond Earth. From massive volcanoes to vast canyons, from mysterious dust devils to breathtaking sunsets, it's a world begging to be explored. So what was your favorite Mars fact from today's video? And which planet would you like to see featured next in this remastered series? Drop your thoughts in the comments below. I'd love to hear them. For now, thank you so much for watching and joining me on this Martian adventure. I hope it gave you a little more insight into our neighboring planet. And if you're someone who loves space as much as I do, I have something that might interest you. We've just launched a new collection of stunning displays that bring the wonders of the solar system to your walls. We've got 40 beautiful metal posters in the collection, each showcasing different celestial objects in our solar system, including brand new Hubble-inspired nebula designs. There's a moon collection focusing on the moons of Jupiter and Saturn, and 2 versions of our planet posters. one showing close-up horizons and the other full planet disks with their accompanying moons. These designs are based on real imagery wherever possible, and I've even put some up in my own home. They're perfect for anyone who wants to bring the awe of the cosmos into their everyday space.